Java 9 Network Programming Section 3 Introduction. In this section, we will be programming applications. We will implement various application protocols to send, receive mail, transfer files, log into a server using SSH, and we will even create a very simple IRTS bot so that we can log in from our Java code to an IRC server. First, we will look at how we can filter clients. It's important for some security. Then we will create an IRTS bot. Then we will send mail, then receive mail. Then we will have a look at how to program FTP. And finally, we will program SSH. Java 9 Network Programming Filtering Clients. In this video, we develop further the client screening, the client filtering. And in this application, we will have not only a server class, but we will have two other classes and a configuration file. The configuration file is simply a properties file, which means that we have in the properties names and then values assigned to it. The names are ASCII names and equals, and on the right side what we have are the values. In this case, what you can see, we have configured two values in this properties file. One is named allowed, the other one is named denied. Both of them are strings, and these strings will be used as regular expressions. And these regular expressions just represent the clients which are allowed. So if any of the regular expression matches our client IP address, then it's allowed. And with the denied, if any matches the IP address described by this regular expression, then it's going to be denied. The regular expression which says it's allowed means the regular expression says that the IP is 127.0.0. and anything. So if the IP number of the client is on the local host, which is 127.0.0.1, but it can be anything else, not only one, but two, and so on. Or if we use IPv6 localhost numbers, so we have a 0 and a colon, and then we can have it at most 7 times and a 1 at the end, then it's the localhost, then it's allowed. But if somebody comes from the local area network, but not from the localhost, and if this local area network is numbered with 192.168.0. something, then the connection will be denied. This IP address, 192 and so on, is very many times assigned by the Wi-Fi routers in homes, and it's used as a private area, private address range. So it's not just very made out of something, it's a real example. For the configuration reading, we have an interface which defines how we can read the configuration. For such a small program, perhaps creating an interface is an overshoot, but nevertheless, here we are. In this configuration, we have two methods. One returns the collection of the allowed IPs, and the name of the method is getAllowedIPs. And the other one returns the collection of strings with the denied IPs, the regular expressions for the allowed IPs and the denied IPs, and the method name is getDeniedIPs. The configuration reader implements the config reader. This is the constructor, and then getConfig inside the configuration reader returns the configuration, which just returns the allowed IPs and the denied IPs. So actually, we do not implement the interface in a separate class file. We implement it extending the interface with an anonymous class, and it's inside the configuration reader, and this instance is returned by the getConfig. and it's a very clean coding style. The configuration reader creates a properties object, then it tries to load it from the resource named filter.properties. We were just looking at this file before, and then calculates the list of the strings from the allowed and denied properties, splitting up the values along the commas using the split method of the string allowed IPs CSV, and CSV stands for comma separated values in this case. So we read the data here and then we split it up into a list, and then we store it in these final lists, which are collections, and then we return them. Perhaps it could be even more elegant if I don't say that these are lists. I can just say these are collections, because we are not really interested in the ordering. Now our code is even more elegant. The Echo server is very similar to what it was before, but now we implement the isAllowed a little bit differently. Here we are calling the isAllowed as in the previous example, but now we are using the host address as a string. And if we are allowed, then we serve the service, the client. Otherwise, we just close the socket, as we did in the previous example. isAllowed just says that we get the config, we get the allowed IPs, and we create a stream out of it. And if any of these matches the host address, note that any match is a stream method, but host address matches is actually a regular expression matching. And if config denied IPs stream none matches the host address, then we are allowed to connect. With the streams API and the regular expression method reference, the code is very simple, very elegant, and very readable. Servicing the client is exactly the same as before. Now let's start the server. Well, it started. And then I telnet to localhost. And I'm connected and the echo is working, it's answering. Now let's modify a little bit the code. And I also stop the server. And then just let's swap what is allowed and what is denied. Now connecting from the localhost is denied and from anywhere else is allowed. But since I'm working on one machine, I'm connecting from the localhost. I start the server again. And I connect to the telnet server. I connect to the echo server. And as we expected, the connection is closed by the localhost, closed by the server, because right now we were starting the server in a way that it does not allow any connection from the localhost.